Hello everyone. So today we're going to do a revision session from PAC, and before we actually do the revision, we're going to have a chapter 5 revision by Mohammad. So today's revision is going to be very, very simple, and it's going to be short because you guys have an exam tomorrow, so we're not going to try to make it long. And we're going to solve some questions with you guys for the previous chapters, which were already done by PACademia. So we're going to go from chapter 4 to chapter 1 because I think most of you found chapter 4 the most difficult. But like I said, before everything, we're going to have chapter 5 revision. And yeah, let's start. Okay.
طيب ماشي يلا I'll start. طيب ماشي يلا هلا guys we'll start. طب بس before we start guys don't forget our brothers and sisters in Palestine and do not ever underestimate the power of dua, okay? Always pray for them all the time, okay? Okay يلا let's start. Bismillah. Okay, the first of all, the definition of stereoisomerism. It's stereoisomers have the same structural formula, يعني they are connected the same way, ماشي? But they are arranged differently in 3D. And these are the different types of isomers. My colleagues have talked to you about the structural isomers and the conformational isomers, the conformers. And now we'll discuss the rest here today. طيب, let's start with some definitions. ماشي. Chiral. Chiral means when you have something and the mirror image of it cannot be superimposed on itself. We're gonna discuss هلا what does superimposed mean. Achiral, the mirror image is superimposed. ماشي. والenantiomers non-superimposable mirror images. هلا we'll see them in pictures. ماشي. These are enantiomers. ماشي. هدول two molecules. This is the mirror image. When you put them on each other, ماشي, this is the CH3, it's on top of the CH3. The ethyl is on top of the ethyl, but the rest are not on top of each other. OH, no matter how much you rotate them, they will not be on top of each other. This is the meaning of non-superimposable. Whereas this is an achiral molecule. If you rotate it, they'll be superimposable, meaning the H will be on the H, the H will be on the H, the ethyl will be on the ethyl, and the methyl will be on the methyl. Okay. Now, also during this session, we'll answer also the assignment question. You guys also asked for it. طيب. Which of the following object is chiral? Okay. Can someone answer? This is an easy question. It's just common sense.
D.
D. Actually, when you put a shoe on the mirror, and you get this mirror image, it will not be the same shoe. ماشي. Like the shoes you have. The right shoe, if you put it on the left shoe, it will not be superimposed. But the paper clip, pencil, egg, they are superimposable. Okay, this is now pure. The second one is pure memorization. Chiral molecules that have non-superimposable mirror images are enantiomers. Pure memorization. Okay, these are the answers. طيب. Now هلا 5.2 stereogenic centers. Stereogenic center means the carbon with 4 different groups attached to it. ماشي؟ يعني مثلا if I see هلا I'll draw. Wait a second. Okay. Here, if a carbon مثلا have double or triple bond, it will never be a stereogenic center because carbon makes 4 bonds, and the 4 bonds should have different groups. يعني مثلا let's see this example. So here we draw the C. The first one is the H. Second one is the CH3. And the third one is the chlorine, and the last one is the ethyl group. See how all of them are different? This is a stereogenic center. This is what we mean. And the stereogenic centers are the ones that will form the enantiomers. طيب. هلا هون, how many stereogenic centers are present in the molecule? Let's do one by one. This carbon is bonded to 3 hydrogen. Okay, the 3 hydrogen are the same group. خلاص, it will never be chiral. Now this carbon, this one in purple, it's bonded to a hydrogen and this thing and 2 methyl groups. Because they are bonded to 2 methyl groups, it is not a stereogenic center. ماشي? Now, let's see this one. This one is bonded to a methyl group, a hydrogen, and bonded to a group that has 3 carbons and bonded to another group that has 4 carbons. These are 4 different groups: a methyl group, a hydrogen, a group that has 3 carbons, and a group that has 4 carbons. These are 4 different groups, and it is a stereogenic center. Let's put a mark on it here. Okay. Now, this one, bonded to methyl, hydrogen, something that has 2 carbons, and something that has 1, 2, 3, 4, 5, 5 carbons, is then bonded to 4 different groups, even it's a stereogenic center. Let's put a mark on it. This one is a methyl group. Methyl group is never a stereogenic center. And this one is this carbon is bonded to 2 hydrogen, bonded to same groups, not a stereogenic center. And this one is not a stereogenic center because it's a methyl group. Then the answer is 2. Okay, the 2 highlighted ones. Right. Now this one, the R and S convention. This is where most students are always confused, and it came a lot in the midterm. So please, guys, focus. طيب, هلا now we'll mention the rules, and then we'll do some examples عشان you guys understand. طيب. First of all, are you guys familiar with the wedge and dash? This one? Guys?
Yes.
Yes, okay. خلاص. Good. طيب. ماشي. The first rule is that we put the species with the least priority at the back. It means with the dash. This is the standard rule, but we can play around with it. I'll show you with the example. But the standard rule is to put it in the dashed one, meaning behind the plane of the page. طيب. Now, the higher the atomic number, the higher the priority. This is what's called the CIP. Where the more we increase the atomic number, the more we increase the priority. And if they have the same atomic number, meaning they're the same element, like methyl and methyl, both carbons, we look at how many bonds they are. So carbon is bonded to hydrogen, and this carbon is bonded to another carbon. The carbon has a higher priority than hydrogen. ماشي? Now the fourth one is when you have a double bond, it has a higher priority than a single bond. ماشي? Because this is how you treat a double bond when you're treating with R and S convention. Okay, and the third bond, triple bond, has a higher priority, and also if you have a carbon single bonded to O, it has a less priority than a double bond. Right. If the rest rotate clockwise, then it's assigned as R. ماشي, and you can think of it as R. It's the right thing because this is what you see on the clock. And if it's counterclockwise, you give it as an S. You think of it as strange. It's strange if something rotates counterclockwise, like the clock, for example. Right. Now examples. ماشي? We'll do examples when they give you on the test when the least priority is at the back, like these two examples, and when the least priority is on the wedge. ماشي? And when it's not on neither. So I'll teach you ways how to rotate, and I'll teach you how to assign the configuration without rotation, because most students are always confused with rotating the molecule. طيب ماشي. First one, easy. Bromine, fluorine, and chlorine. Bromine has the higher atomic number, so we give it as 1. ماشي? Here, fluorine has less. Fluorine has the less also. because here we're rotating 1, 2, 3 clockwise, we give it as an R. Okay? Same thing here. Bromine here has the higher priority. Then chlorine, then the carbon. ماشي? Here, the hydrogen should be at the back. The least priority should be at the back. When we're rotating, it should be R. Okay? 1, 2, 3. طيب. What if I have the hydrogen on the wedge, meaning it's coming to me, okay, pointing towards the front. ماشي? Here, I'm sure Dr. Najjar and Dr. Adaisan told you you have to rotate it. ماشي? But there is a cheat sheet method you don't need to rotate. How? I do it normally. So a propyl group has a higher priority than an ethyl and a methyl. ماشي? I do it normally. Here, it will rotate. It will be, you think it will be an S, but you do the opposite. ماشي? So here we rotated counterclockwise. ماشي? We rotated counterclockwise and we said it should be an S. But because the least priority is on the wedge, I can do the opposite. So this is an R. Okay? You guys got this?
Can you repeat again, please?
طيب. ماشي. Here we said no, it can the least priority should be at the back here. صح؟ صح؟
Yes.
Yes. طب what if it's on here? ماشي. Here مثلا Dr. Najjar and Dr. Adaisan, they told you have to rotate. But students always have it hard. يعني they don't know how to rotate a molecule, and even it's hard to teach it online. ماشي.
I know how to rotate, but
Okay.
how to name?
How to name?
Yeah.
Naming is not in this chapter. بس
No.
يلا.
Okay.
طيب ماشي. Look, here if we have an H on the wedge, ماشي, you do it normally. So a propyl group has the highest priority, right?
Yes.
Okay. Then the ethyl, then the methyl. Okay. And then if you rotate from 1, 2, 3, it will look like it's an S. But because here the H is on the wedge, I do the opposite. I give it
so we named opposite. We name R.
We name it R. It looks like it's an
I
S. Okay. But if it's on the dash, you do it normally. You don't do opposite.
Okay, thank you.
طيب. ماشي. Now this one. This one. Here, this is an example when it's neither on the wedge nor on the dash. Here, when we need to rotate, there is two ways to do it. One with rotating and one without. Okay? طب يلا, let's start with the first one. How do we rotate a molecule? Okay. First of all, here مثلا we have at the top the carboxyl group. Okay? We keep it as the same. So here, carboxyl group pointing upwards. COOH, carboxyl group. And then I move everything clockwise or counterclockwise. ماشي? But here we need to move it counterclockwise to put the H on the dashed. Okay, on the dashed plane. So we move everything counterclockwise. So here I move the H to the dashed, and the H will be here. And then this methyl group will move here, will take the place of the amine. Okay. And this is CH3. And then the amine will take the place of the H. Okay, do you guys now understand how to rotate? Easy, right?
Yes.
Okay. Right. Now we do it normally. So which one has the higher priority? Amine or carboxyl or methyl?
Carboxyl.
NH2.
NH2, yes. Because nitrogen has a higher atomic number than carbon. So we give it 1. Then the carboxyl, because here we have carboxyl and methyl. But because oxygen has a higher atomic number than hydrogen, this one is the second priority, and then this is the third one. And then here it's rotating counterclockwise. So this is an S. Okay? Right.
Sorry, I have a question.
Okay, what's your question?
Do we get the entire molar mass for each molecule, or only the first element?
You will have the periodic table with you.
Yeah, we will be having it inside the exam, but I'm like confused. So I need to calculate them all, or like the first element per like section?
It's the first element. You look at, like, for example, sorry to interrupt, but يعني, if carbon and nitrogen, you're looking at the element itself. Nitrogen has a higher atomic number than carbon. That's how you do. You don't take the
Yes.
whole substituent.
Look, يعني مثلا if you find carbon has atomic number of 6, and here nitrogen is 7, so you give nitrogen a higher priority. ماشي?
Okay, got it. Thank you.
Okay. Right. Now this is the rotating method. But what if I'm still confused about rotation? There is another method. Right. Here I just swap between between these two. Okay? But when you swap between any two, so here I swap with the methyl and the hydrogen, and I keep everything the same. When you swap, you're gonna invert it. ماشي? So for example, here you do it normally. This is 1, this is 2, and this is 3. I rotate, it looks like it's an R, but the original one معناتها it was an S. Okay? This is the second method. Okay? The first method is you rotate. The second method is you swap, and then do it normally, and then you invert your answer. Okay? Use which method you're comfortable with.
So you can swap any two?
When you swap any two, هلا بس we need to swap the hydrogen and put it in the back so that we can make it. But when you swap any two, you're gonna invert the stereochemistry. يعني for example, let's say this was an S. If you swap this with this, you'll get an R. Or if you swap this with this, you'll get an R. ماشي?
Okay.
Okay. Okay, يلا, let's do هلا now the second one here. We're just gonna do rotation. Again, we'll keep the ethyl group on the top. Okay, and now we'll rotate clockwise so that the hydrogen is on the dashed plane. Okay, then we'll move the Cl here. And then we'll move the methyl here. Okay, CH3. Okay, the highest priority here is the chlorine, then the ethyl, and then the methyl. We're rotating counterclockwise, so it's an S. Okay. Do you want me to show you the other method, or you guys got it?
Yes, we got this.
Okay.
But
Done. Yes. What's your question?
but what is the another method?
Another method is when you swap between two. So you swap, for example, between the chlorine and the H, and you do it normally. So here, look, I'll do it for you. Here, CH3, CH2, and here I told you. Wait, let me delete this one. I swap between these two. So I put the hydrogen here at the back, and I leave the rest the same. Okay, now do it normally. 1, 2, 3. So here you're rotating clockwise. So it looks like it's an R, but the original one is an S. You invert your answer if you swap between two. Okay?
So CH3 would remain at its place. You
Would
like
remain at its place if you use the second method, but if you
Uh-huh.
rotate, it will not remain on the same place. Okay?
so this method you are not rotating. What?
And we're not rotating. No, we're just using a cheat sheet. يعني it's a cheat method. ماشي عشان to make it easy for you.
Okay. Thank you.
Okay? طيب ماشي. هلا now the question. Okay, this one, the first question, easy. Can someone answer?
C.
Yes, C. طيب. Why C? Because here oxygen here has a higher priority than carbon because oxygen has a higher atomic number. ماشي? And then a carbon double bond has a higher priority than a single bond. And here, because we have two carbon here, it has a higher priority than one carbon. Okay? طيب. Now the second one. طيب. Which of the three molecules below is the enantiomer of the following molecule? طيب. How do we know? We need to find whether this is an S or the R. Enantiomers have opposite configuration. Okay, and if the first one is an S, the other one will be R, and so on. طيب. ماشي, let's work it out. First of all, if I don't know if you guys noticed this here, this is in the assignment, they gave you the exact same molecule for this one. If you guys notice, these two are the exact same thing. Okay, so these two can't be enantiomers. They are the same molecule. طيب. Now that we canceled the first one, طيب. Now let's find the stereochemistry of this one. Okay. Which one has the highest priority, iodine, bromine, or methyl?
Bromine.
Isn't it iodine?
Yes, iodine. Iodine because it has a higher atomic number. Okay. So we put it as 1. And then bromine. And then methyl. Because we're rotating counterclockwise, it's an S. Okay. طيب. Now we do it for this one. When I said when we have the least priority group on the wedge, we do it normally and then we invert our answer. Okay. So this one is highest priority, as you guys said, and then 2, and then 3. We're rotating clockwise, so it looks like it's an R, but we invert our answer and it becomes an S. Okay? So this one is an S. So these two molecules are actually the same thing, exact same thing. And if you guys also rotate this one, this molecule here, like this one, like that, clockwise, you put the bromine on the place of iodine, bromine, and you put the iodine on the place of hydrogen, and you put the hydrogen at the back, you'll find it's the exact same thing. طيب. ماشي. Now let's delete. طيب, now let's look at the last one. Okay. Now this one here, we need to rotate. Okay, we'll keep one that's on its place. Okay. So here we'll choose, for example, the methyl, and we need to rotate so that the hydrogen becomes at the back. And so we'll rotate it counterclockwise. So here, the methyl, same place. Now we'll rotate counterclockwise. So the bromine will take the place of hydrogen. So bromine will become like this. Hydrogen will take the place of iodine. So hydrogen will become here. And iodine will take the place of bromine. No, sorry, this one should be bromine. Iodine, sorry. Okay. Iodine, and this one is bromine. Now we do it normally. This one is 1. This one is 2. And this one is 3. Okay. So this one is an R. Okay. And the original one was an S. So these two are enantiomers. So here the answer is A. You guys got it?
Yes.
Yes.
Okay. ماشي. طيب, now Fisher projections.
But just can you go to the last example that you did?
Which one?
Yes, this one. So
Yeah,
we
what's your
have
question?
the right side, 1, 2, 3 for iodine and bromine that you wrote.
Oh, here?
Yeah, here. How do you? No, it's not like in order. Oh, okay, right here. So this is counter clockwise, yeah.
This is clockwise.
Clockwise,
Here,
yeah.
here. 1, 2, 3. This is 1. Here, wait. This is 1. This is 2. And this is 3. We're going clockwise. The same direction of the clock.
Now I got it. Thank
Okay. Good. Right. Now Fisher projections, they're used to represent the 3D molecule in a 2D way. So this is actually a 3D way. Because the dash is going at the back and the wedge is coming towards you, and these two are on the plane of the page. Okay. So how do we assign for Fisher projections? Some people I've seen them, they just like to convert it the same way in the textbook, but no need actually. We do it the same way. Okay. So if here مثلا, let's do it normally. Okay. Here hydrogen is coming out of the page. Okay. So we have to invert our answer. So here, the first one, the highest priority is the hydroxyl group, then the carboxyl, and then the methyl. We're rotating counterclockwise, but because hydrogen is on the wedge, which is the least priority group, we invert our answer, and it becomes R. Okay. If hydrogen was on here or here, we don't invert our answer. Okay. But and if you want to convert it like that, sure, but it will take you time in the exam. But now let's do it here. Let's do an example of Fisher assigning configuration in Fisher projection. Okay. So here the bromine, this is bromine, this is carbon attached to a chlorine, and this is a methyl group. Okay. So this bromine is the highest priority. It has the highest atomic number. Then the carbon here, because it's attached to a chlorine, and this one is the last priority because this carbon is attached to hydrogen. Rotating counterclockwise. But because here hydrogen is coming out of the page, okay, it will be an R and not an S. Okay. When it comes out of the page, we invert our answer. When it doesn't come out of the page, it comes out of the page when it's in the horizontal bonds. Okay. Now, same thing here. This one, chlorine has the highest priority, this carbon, and then this carbon. Same thing. We're rotating counterclockwise, but hydrogen is coming out of the plane of the page. So it's not an S, it's an R. Okay. Well, this is the answer. طيب. Now هلا assignment questions. طيب. هلا now, which of the following molecules are the same? Okay. Let's do it one by one. طيب. First of all, we need to name them. Before doing R و S ومدري شو, we need to name them. Okay. This one is 2-chlorobutane because this butane because the longest carbon chain is four carbons, and then chloro is coming out of the second carbon. Same thing here, 2-chlorobutane. Same thing here, 2-chlorobutane. Okay, here there are two problems. First of all, this is not 2-chlorobutane. this is 2-chloro, and then there is a methyl group coming. This is not this molecule is not the same because there's a methyl group coming out of the second carbon, unlike the other three. Second of all, this carbon is not a stereogenic carbon because we have the same group attached to the same carbon. Okay, so we cannot even do here R and S. To do R and S, the 4 groups should be different. Okay, so this one we take it out of the choice. Now let's do the other ones. Right. First one. Okay. Can someone do it?
The naming or the R?
The R and S. No, the R and S. Okay.
First, we look that color is the highest priority.
Good job. Chlorine has the highest priority. Which one is the
Then-
second priority?
Ethyl and then methyl.
Ethyl, then methyl. Good job. Okay. Then it's rotating clockwise or counterclockwise?
Counterclockwise.
No, this is clockwise. Clockwise. Look, 1, 2, 3.
Yeah. I mean clockwise. Sorry.
Clockwise. Okay. So it's R or S?
When it is R,
R.
but we say opposite, yeah.
Yes, it's R. This is clockwise means R, but it's opposite because H is
Yeah.
coming outside of the plane. This is the dash 12. So this is actually an S.
Yes, yeah.
Okay. طيب, this one. Same thing. Chlorine, then ethyl, then methyl. Okay, because
This
here
one is
it's
R.
yes, this one is R, rotating clockwise, and the H is at the back. We do it normally. We don't invert our answer. So this one is R. Okay. Right. Last one. This one is chlorine, first one, then ethyl, then methyl. Here we're rotating counterclockwise.
S.
So S. ماشي? And here H is at the back. We don't invert our answer. So this one is an S, and this one is an S. ماشي? So this means that 1 and 2 and 3 are the same molecule. Okay? 2 is their enantiomer. 2 is the mirror image of the 1 and 3. Okay? So here the answer is C. طيب?
But just I have a question.
Yes.
Why did you name them at the beginning stage?
Why did I name them?
Yeah.
Because they might trick you and just tell you, which molecules are the same, and you just work out the R and S without looking at their naming. For molecules to be the same, they should have the same name and they should have the same R and S convention. Okay?
Okay.
Okay. طيب. First of all, هلا we'll see it in this example. طيب. R2-chlorobutane is correctly represented on which of the following? Okay? طيب. Now, before we say it's R or S here. Before we say it's R or S, we'll see which one is 2-chlorobutane. Is this 2-chlorobutane? This is carbon number 2, and this is butane, and a chlorine coming out of carbon number 2. And so this is 2-chlorobutane. Okay? We put a tick around it. Same thing here. Longest chain is butane, and chlorine coming out of it. So it's also 2-chlorobutane. Here, the longest chain is butane, but there is a chlorine coming out of it and a methyl group. So this one is not 2-chlorobutane. We take it out of the choice. And also, second of all, this one is not a stereogenic center. We can't say it's R or S. Okay? Like this one. This one, the longest chain is butane. ماشي, but also chlorine and a methyl coming out of it. And also, it's not a stereogenic center. We take it out of the choice. We don't deal with it. ماشي. And here is this 2-chlorobutane? Yes. ماشي. There is no methyl group, extra methyl group. طيب. Now let's deal with these three. These three. ماشي. طيب. Yeah. Chlorine, same as the previous example. 2-chlorobutane. We do the same thing. This is 2 and this is 3. We're rotating clockwise, so it looks like it's an R, but it's actually S. Okay, because of this hydrogen coming outside. Like this one. Here, chlorine number 1, ethyl number 2, and methyl number 3. So we rotate counterclockwise. Best, so it looks like it's an S, but it's actually an R because of this hydrogen coming outside. Right. ماشي. This is R2 chlorobutane, so this is our correct answer. So let's see the last one. ماشي. 1, 2, 3. Rotating clockwise. So it looks like it's an R, but because this hydrogen is coming outside, it's actually an S. So these two molecules are the same. Okay. طيب. Now let's go back and see our answer. يلا بسم الله. Okay, so this is our answer 2, as we said. Okay, got it, guys?
Yes.
Okay, good.
I have a question.
Yes,
If the chlorine is locating inside, the naming will be the same, right?
yes. You only it only differs when the least priority group is pointing inside or outside.
Oh,
Okay.
okay, thank you.
Okay, if the highest priority group is pointing anywhere, it doesn't matter. Okay, now the EZ convention. Okay, it's same as cis and trans as the my other colleagues taught you. Thus, here we're dealing with instead of different groups instead of the same ones. Okay, we also use the CIP. This is the CIP, guys. This rule, the Kahan in gold prelog, the one I showed you before. These rules also deals with them. Okay, so which one is on different? So if you guys remember, trans means on opposite side and cis means on same side. Okay. Here Z means on the same side and E on the different side. And if you want to remember, this is a mnemonic for you, same side. Okay. Z is on the same side. Okay. Right. How do we find E and Z for this molecule? Okay. First of all, you put a plane here. You divide the molecules into two halves. You put a horizontal plane. Okay. And then you find the priority with atomic number. Okay. Here you compare fluorine and hydrogen. Fluorine has a higher atomic number than hydrogen, so it has the higher priority. Chlorine has a higher atomic number than carbon, so it has a higher priority. So is this Z or E?
Z.
Z, because they are on the same side. The two ticks are both below the plane. Okay. Can someone name this molecule? Yalla, from previous chapter naming. Do you guys remember?
2 chloro, 1 fluoro, 1 Z, 2 chloro, 1 fluoro, what's it called? 1 propene.
Good job. Okay. 1 propene or 1 prop1ene, the same thing. Okay. Z, 1 fluoro, 2 chloropropionene. Amazing. Right. Now
Doesn't naming propane doesn't need a 1?
Yeah.
So it's only
Here.
propane, not 1 propane. Or 1. Okay. Never mind.
Right. ماشي. Now, of the following structure, how many are classified as Z? Okay, we do the same thing. If the highest priority are on the same side, we put them Z. If not, they're E. So here, methyl or hydrogen. Methyl has a higher priority because carbon has a higher atomic number. Methyl or ethyl. Ethyl. The two ticks are on the opposite side, so this one is an E. Okay. Here, chlorine has a higher atomic number than carbon, so it's both. So this one is Z. Okay. Now this one. Methyl or hydrogen. Methyl because carbon has a higher atomic number. Now this one or this one. This one because it has a double bond. Okay, and let me show you again. This one. Yes, here. Now we treat this one as it's like that. So this one technically has more carbons. Okay. طيب. Let's go back. Okay. إذا this one and this one. So it should be here. So this one is Z. This one and this one Z. Okay. Now this one, chlorine here has a higher priority than carbon. Okay, so chlorine here both has a higher priority. So this one is an E. Okay. Okay. And here also chlorine, the same thing. So this one is an E, right? Okay. But now polarimeter. What is a polarimeter? Device used to determine whether the enantiomer rotate to the right or left. Okay. So when we have a polarimeter, okay, and we put each enantiomer, the both R and S, one will rotate to the right and one will rotate to the left. Okay. If a substance rotates the polarimeter, we call this substance as optically active molecule or optically active substance. If it does not rotate, it is an optically inactive substance. Okay? طيب. What are the two rules for substance to be optically active? Number one, it should have a chiral center. Okay? Or a stereogenic center, as you guys call it. And it does not exhibit a plane of symmetry. Okay, we'll talk about it now when we reach 5.9. What does plane of symmetry means? Okay? طيب. ماشي. If an optically active substance rotates the light to the left, we call it levorotatory. Okay? So how do you guys remember it? Both start with L, and here levorotatory is the negative. They assign it as the negative. So you can think of it as the left is the negative hand in Islam. So you guys are not allowed to eat with the left hand. So it's a negative thing. Okay? And if it rotates to the light, the substance is dextrorotatory, which is the positive hand in Islam, because you eat with the right hand. You should eat with the right hand. Okay? طيب. ماشي. If you're in a lab, for example, and they give you two enantiomers, how do you distinguish between them? Using a polarimeter. If it rotates clockwise, it's dextrorotatory. If it's rotates counterclockwise, it's levorotatory. طيب. Now these are the rules. Achiral molecules are always optically inactive. Okay? They are always optically inactive because one of our rules, it should have a chiral center. Okay, here. Achiral molecules do not have a chiral center. Now, chiral molecules are optically active unless there is a solution with equimolar mixture of both enantiomers. Yani, what does this mean? Yani, for example, if I have two substances, one R and one S, and I mix them together equally, so I have 50% R and 50% S. If I put the mixed substance in a polarimeter, it will be optically inactive. Okay, and this, when we have equal mixtures of enantiomers, we call it a racemic mixture or a racemate. Okay? Racemic mixtures are always optically inactive. Okay? Because both the rotations of two enantiomers cancel out each other. And one wants to rotate to the left and one wants to rotate to the right. But so these two rotations cancel out each other. Nothing actually rotates. Okay? But what if I have, for example, a mixture of 60% S and 40% R? This substance will be optically active. Okay? Right. Now, specific rotation. Okay? This one, I don't think it's important in my opinion. It did not come last year in the midterm, and I think did not come also in the final or only one question. Okay? But guys know it because the Dr. Najjar said it's part of what you should study. Okay. What is specific rotation? This specific rotation, it measures the exact amount of rotation of the molecule in the plane polarized light. Okay. By the way, guys, if you have any question, feel free to stop me. Okay. Do you guys have question about the last ones? What I discussed? Okay, good.
I didn't get the racemic mixture. What is
Okay.
for? It's like it is like optically inactive, but what was the difference with the chiral?
طيب ماشي look هلا نحن we said انه chiral molecules are optically inactive because they don't have a chiral center. You got this, right?
Yes.
Okay. طيب what if I have, for example, here a solution, this one, an R solution, and a solution that has the S isomer. Okay? ماشي? And I mix them together so that 50% of this solution is R and 50% is S. ماشي? I mix them together.
Mhm.
ماشي؟ طيب. Now if I put this mixture in the polarimeter, will I see any rotation? Will it rotate to the right or the left? No. Why? Because they cancel out each other, because one will want to rotate on the right and one wants to rotate to the left. ماشي? But because they are equal, no rotation will happen.
I get it.
Okay, it's like when you're playing, you have a rope and one is pulling it to one side and one is pulling it to the other side, but both of you guys are pulling it with the same force. The rope will not move.
Yeah.
Yeah,
I get it.
like this. You can think of it like this. Right.
So in here, one will rotate to the right and one to the left, and they cancel.
They cancel. So if they ask you in the exam, is racemic mixture optically active or inactive? You say optically inactive.
Yes.
Okay. طيب. Good. طيب. ماشي. طيب, why observed rotation is not enough? Yes, if I see that the rotation of the light, okay, why it's not enough? So I can just record it's 50 degrees or something, because the exact rotation depends on many factors. Okay, it depends on the concentration of the enantiomers, the temperature, the wavelength of the light, okay, and the molecular structure. These ones are the one on the slides, and this one I got them from the textbook. Okay, so you can focus on the first three, and the molecular structure of the enantiomers and the length of the tube. Okay, and this is the formula. Okay, this one is the observe in degrees. So for example, you observe 30 degrees, and then you put the concentration of the solution, and then you put the length of the tube. That's what you need to know. Okay, but as I said, it did not really come last year, but it could come. Right. Now, properties of enantiomers. Enantiomers have identical achiral properties. What does this mean? Yani if I react both enantiomers with an achiral molecule, okay, I will have the same outcome, the same observation, everything. They have identical physical properties. They have the same melting point, they have the same boiling point, they have the same density. They only differ from each other with the properties that are chiral. Like, for example, as we said, rotating the plane polarized light. One rotates to the right and one rotates to the left. Okay? the chemical properties of enantiomers are identical with compounds that are not optically active. What does this mean? Yani if I have an R isomer and I reacted with an achiral molecule, and I have the other S isomer and I reacted with an achiral molecule, I will have the same outcome. ماشي? Nothing different. Type now this one. There is no obvious relationship between the R and S configuration and the sign of levo and dextrorotatory. This came last year in a question. Okay. So you guys need to memorize this. Yani, for example, what does this mean? What does this sentence mean? Yani, if I have a R isomer, will it always rotate to the right? لا. If I have the S isomer, will it always rotate to the left? لا. But if the R isomer rotate to the left, the S should rotate to the right. Okay? You guys understand this? If you don't understand it, tell me, because it came last year.
So they should be always in opposite direction.
They could be in opposite direction, but it does not mean that the R isomer should rotate to the right. It's not a specific rule. Okay, it could rotate to the right or the left. Same thing with S.
So if for example, if the S rotate to the right, the R should rotate to the left.
Correct. ماشي, but the R could rotate to the right in another substance. Okay. Okay. طيب.
Okay.
Enantiomers behave differently in biological systems. Okay, you just need to know this. You don't need to know example. But your textbook mentioned there are adrenaline. Adrenaline is the molecule that increases your heart rate. One enantiomer works in your body, but the other does not work. Okay, this is an example mentioned in your book, but you don't really need to focus on it. Now diastereomers. Diastereomers stereoisomers that are non-superimposable or non-mirror images. نحن enantiomers, what did we say? Enantiomers, we said they are mirror images but non-superimposable. Here both non-superimposable and non-mirror images. When do we have diastereomers? Two situations. Cis and trans and EZ they are also called diastereomers. Okay, you guys know cis and trans and E and Z. طيب. What about when more than one chiral center is present and they do not differ in the R and S configuration? What does this mean? And for example, when I have a molecule with more than one chiral center, one for example is R and one is S, the enantiomer, what will it be? S and R. All of them are opposite. But diastereomers, one is opposite and one is the same. Okay? So remember, enantiomers, they have opposite R and S in all the chiral center. But diastereomers not. Okay, here an example. Look, here we have this molecule and this molecule. These are enantiomers, these two. Why? Because this one is R, this one is R, and the other two are S. Right. Here also we have an enantiomer. Here R, S, and this one became an S, and this one became an R. So these are enantiomers because they differ in all of the chiral center. So where are the diastereomers? Diastereomers, for example, is this one with this one. ليش? Because these two are different, but these two remain the same. Okay? You guys got it? Here, for example, number 2R, number 1 is 2R and 3R. Number 3 is 3R and 3S. They differed by 1. Here also they differ by 1. 2R, 3R. The 3R remain the same. This 2R became 2S. Okay, and this one, and the same thing with the rest of the examples. Right. What about diastereomers? What about their properties? Diastereomers, they differ in both chiral and achiral properties. Remember, in enantiomers, only achiral properties they differ. Okay, but in diastereomers, they differ in both chiral and achiral properties. They behave as two different substances, and also different physical properties. Yes. What's your question?
Okay, so diastereomers are basically compounds that have two chiral carbons, and one of the carbons is like the same, like either or both of them are R or both of them are S, but then the other one is different?
Yes. Okay. or
Okay.
not just 2, even more than 2 ماشي. بس enantiomers all of them should be the opposite, all of them.
Oh,
ماشي.
enantiomers can also have multiple chiral centers.
Yes.
Okay, تمام.
ماشي. يعني I'll give you an example. If this one is, if we have 2R, 3S, and 4S, for example, what's each enantiomer be? It will be 2S, 3R, and 4R. All of them are opposite. This one is opposite. You got it?
Yes.
But
And then in
diastereomers, not all of them are the opposite.
okay.
Okay. Right.
Thank you.
Now this one, this formula is helpful. Okay. What's this formula? 2 to the power n. N is the numbers of stereogenic centers. ماشي. What will this give me? The number of stereoisomers. ماشي. And for example, this one has 2 chiral centers, right? So if I do 2 to the power of 2, I will get 4. So this one I have 4 stereoisomers, and you guys can see 1, 2, 3, 4. Okay. There is an exception to this equation. We'll discuss it later. Now at the end. But now mesocompound. Mesocompound are achiral diastereomers with stereogenic. يعني it has stereogenic center, but it's optically inactive, and they are identical to each other. Why are they? Why are they optically inactive? Because of the existence of the plane of symmetry. What does plane of symmetry mean? Plane of symmetry divides the molecules into two identical halves. So this is the rule. Any molecule that has plane of symmetry, it will not exhibit optical isomerism. يعني it will not rotate the plane polarized light. Okay? طيب. Look, this is the plane of symmetry. If I divide this like this, I will get 2 equal halves. This CH3CLH and this one CLH these 2 halves are exactly the same. Okay? طيب. How do we visualize it? Why are these 2 molecules the same thing even though we have the mirror image? Because look, guys, we said enantiomers, they differ with the chiral center. This one is R, this one is S, this one is S, this one is R. Why are they the same molecule? Okay, I'll show you. Because if you I'll get this molecule. If you rotate this molecule 180 degrees, so this one is the same as this one, the left one. If you rotate it 180 degrees, so this is 90 degrees, this is 180 degrees, and you put it, they are now superimposable. Okay, the Cl and the Cl are on top of each other, the H and the H and the CH3 on top of the CH3. Okay, that's why they are optically inactive. Okay, let's put this to the side. Okay, you guys got this point?
Yes.
Okay, good. Now the assignment. Easy. Which of the following molecule has a mirror plane of symmetry? Okay, now let's divide it. Here, there is no plane of symmetry because the Cl and the H, they are not on the same side. Or if you want to have a mirror plane of symmetry, they should be on the same side. Here you divide it. Everything is on the same side. The Cl, the H, the CH3, all of them are on the same side. So this one has a mirror plane of symmetry. Here, this side we have 2 Cls, but this side we have 1 Cl. It's not a mirror plane of symmetry. Okay, here we have an extra methyl group, and here we don't have this methyl group. So here the answer is 2. Okay, you guys got it?
Yes.
Okay, good. Right. Here, which one is achiral conformers? Right. Conformers, you guys did it in chapter 4 or 3, I don't remember. Okay, you guys did it before. So what's the answer? A. ماشي. They keep rotating. طيب ماشي. Why cis and trans? Why when we have a butene when we have a double bond, why do we have cis and trans? Why don't we have conformers? Can someone answer this question?
Because it's limited.
Because it is
rotation.
double.
Because there is double bond. What's in the double bond that
Because the
restricts
double
rot-
bond doesn't
It
rotate.
doesn't rotate.
Yeah, what's in the double bond that restricts rotation?
The pi bond.
The pi
The
bond.
pi bond, yes. The existence of pi bond restricts rotations. Okay. So now here, these two are diastereomers. Why? Because cis and trans are a type of diastereomers. Here, they are also diastereomers, and here, because they are R and S, these two are enantiomers. Okay. Do you guys understand why this one is diastereomers and why this one is enantiomer?
I didn't get C.
C. Okay, let's draw C. طيب. Meso and dibromobutane. Okay, let's draw meso dibromobutane. Okay. Wait a second. Okay. Dibromobutane. So let's draw the Fisher projection. BR, BR, H, H. Okay. Fine. Now, why is this a meso compound? Here, if I put a plane of symmetry, I will have two equal halves of the molecule. And all of them are on the same side. BR same side, H same side, and CH3 are exactly opposite to each other. Fine. Now, wait a second. Okay. Now let's remove all of this purple. Fine. Now let's do R and S. This is BR. Fine. BR here has the highest priority. Second is this carbon, and the third is this methyl, rotating clockwise. That's because this hydrogen is coming out of the page. It's not R, but rather it's an S. Okay. Right. Let's do the same thing on the second carbon. This is an S. Right. Now here, number 1, number 2, and number 3. Rotate. It looks like it's an S, but it's an R because hydrogen is coming out of the page. So this one is an R. Right. Now, here, which one is telling you they are diastereomers? Meso, which is the one we drew now, and 2R, 3R. 2R and 3R. How do we do? Okay, we have 3R. This is carbon number 3. Okay, but how do we do this 2R? Here, you do it like this. So this one is BR. It becomes BR and the H, they flip sides. Okay, because remember when I told you, when you swap between two molecules, you invert the stereochemistry. CH3. Sorry guys for my handwriting. Using my fingers. Okay, BR, H, CH3. This one R, so it remains the same. But because here we flip them, becomes R. Here they are opposite in one stereogenic center, but not the other. You guys got it now?
Yes.
Okay, good. Hi. Now 5.10 is the summary of what we said. Okay, so I'm not gonna go through it. Now 5.11. 5.11 here, where they're telling you what will happen if we do an electrophilic addition. You guys remember electrophilic addition? Do you guys take it?
Yeah.
So. Yeah. Electrophilic addition to butene. 1-butene. Okay. So here we'll form this carbocation. Okay. Fine. Here there are two equal chances. Either the bromine attacks from top or it attacks from the bottom. If it attacks from top, we'll get an S isomer. If it attacks from the bottom, we have an R isomer. Okay? طيب, at the end, what we will get? We will get an equal amount of both, or what we called before a racemic mixture. يعني, if I react these two, I will get an equal amount of the S and R isomers because there are 50% probability it will attack from top and bottom. So the product will be optically inactive. Got it, guys? Okay, good. طيب, this is if I react, if we get a chiral molecule from reacting an achiral with an achiral. Okay? طيب, now what if I have an achiral molecule and I reacted, if I have a chiral molecule and I react it with, and I do electrophilic addition. Okay. First of all, we will get unequal amounts. Okay. طيب. ماشي. And I'll get an equal amount of the R and the S. Okay. And they will be diastereomers. Diastereomer products. It will happen at different rate. Now here here we said, because there was a 50% probability it will attack from the bottom or from the top. Okay. Here I asked the doctor, even here طيب, we have 50%. He said there is an extra explanation to this and you don't need to know it. Okay. But here a simple explanation I heard is that because this one BR, the chlorine has a higher electron density, so it will repel the BR. So we'll actually have more of this and less of this. ماشي, but you guys still don't need to know it. You just need to know that when you have a chiral molecule and you react it with an achiral reagent, you'll get an unequal amount of the diastereomers. Okay? And when you have an achiral, both achiral, here, this one and this one, you will get an equal amount of this and this. You'll get a racemic mixture. Okay? And the product will be optically inactive. طيب. Now the questions. We'll have like 7 questions, 7 questions to test you guys. And then we'll خلاص end the presentation. And if you guys have any question, يلا guys, answer it. I can't, by the way, I can't see the chat. So if you guys say anything, just say it into the mic.
Is it 2?
Is
2?
4?
4. Okay. Why did you say 2?
Oh, stereoisomers. I was looking
Stereo.
for chiral carbons actually.
Yes.
Oh,
Sorry.
okay.
Yeah. It's fine. It's still confusing. Okay, so here you draw the molecule. We have two stereogenic centers. You use the formula 2 power 2 and you'll get 4. طيب. Let's look at a similar question. Do anyone can answer?
Is it 2?
4 بعد.
Okay. Okay, you guys, how many say 4? All of you say 4?
4, yes.
I say it's 2.
Two stereoisomers? Okay, one say 4
Sorry.
and one
4.
4. Okay. All of you guys are incorrect. The answer is actually 3. Right. Why? طيب, here we have two stereogenic centers, and why don't we just apply the formula and we get 4? Why is this different? This can actually come at the exam and confuse you. This is called a meso trap. Meso. طيب. Let's draw. This is the structure of the molecule. صح? Now,
Yes.
this is the first stereoisomer, and this is the second stereoisomer. Okay, the rest are the 2s and 2r and 2r. So you'll say, oh, this is 1, this is 2, this is 3, and this is 4. But no, this is incorrect. Why? Because these two are the exact same thing, meso compounds. So you count them as one. So this is 1, this is 2, and this is 3. Got it, guys? Well, do I really explain?
Can you explain?
Again, please.
Can you
Right.
re-explain what a meso compound is?
Right, let's go back. Meso compound, we said a meso compound is a molecule that exhibits a plane of symmetry. What does plane of symmetry mean? It means if I divide the molecule into two halves, I will get two identical halves. ماشي؟ يعني look here, for example, this molecule, I divided it into two halves. Here I have Cl and H and CH3, and here I have it too. And they should be on the same side. Okay? Here the Cl and R are on the same side. The H and the CH3 are on the opposite. Okay? Meso compounds, even though if you look at their enantiomers, the mirror image, it might look that it's a different molecule, but it's not a different molecule. Why it's not a different molecule? Because when you rotate this molecule, you bring it and you rotate it 180 degrees, it will be superimposable on its enantiomer. Yani look, the Cl will be on top of the Cl. The other Cl will be on top of the Cl. The CH3s will be on top of each other, or everything. So it's the exact same molecule. So these two molecules, chemically, they are identical. Okay? Everything is identical about them.
I have a question.
Yes.
If you have 2R, 3R, and 2S, 3S,
2R,
same
3,
length,
2R, 3R.
and you rotate it 180, wouldn't it also be superimposable?
طب يلا, let's draw it. Let's draw it. طيب. You said 2R, 3R, and 2S, 3S. طيب. This is CH3. And this is, you want it as, this is, okay, we'll draw first the S ones, 2S, 3S. So this is I and H, okay? And this is, here you should put the I, and you should put the H, okay? And then this is the CH3. Okay? So, now, let's draw the other one. Here, you want to draw the mirror image. So this is the mirror. I, CH3, CH3, H, then H, then I. طيب. First of all, you said no, they'll be superimposable. You need to look. في plane of symmetry, there is no plane of symmetry. This is number one. This is number two. Do you want me to actually show you? يعني إنه take a screenshot and try to put them on top of each other?
No, once you drew them, I'm interested.
Okay, good. Okay, so this one, these are the three stereoisomers. First one is this. Second one is this. The third one is this, the one I drew. Wait, let me erase so you can guys see them. ماشي. This is the third one. These two are identical. Same thing. So you count them as one. Okay? So when you see a meso compound, don't just use the formula. Use the formula and then eliminate the meso compound. If there is no meso compound, simply just use the formula and you'll be all good. Right. Now, okay. Someone answer, please.
D.
D. Why D? Can you explain? Okay, any other person? Well, do I go to the answer?
So the enantiomers are like chiral and I think A, I would say.
Yes.
It's
Okay.
A.
It's A. طيب ماشي. هلا نحن okay we said انه chiral enantiomers they differ in the chiral reagent when we react them with a chiral reagent. If we react them with an achiral, they will have the same properties. And it's clear they have same boiling point, same melting point, and solubility in water. طيب why number of degrees they rotate the polarized light? Here they mean انه will it have the different degrees if I rotate it to the right and rotate it to the left? No. If the first molecule, for example, rotated 50 degrees to the right, the other molecules should rotate 50 degrees to the left. They don't differ in the number of degrees. Okay? Clear?
Yes.
Okay, it's clear right now.
طيب. How many stereogenic centers are present in the following molecule? Easy question.
Two.
Two. طيب, why is this one not a stereogenic center?
It attached to 40. Oh, yeah.
True, yeah, you're correct. Say it.
It attached to 4 different.
Yes, correct. It should attach to 4, but here it's attached to 3 different molecules. And because it's a double bond, so it's not a stereogenic center. So correct. These two are the stereogenic centers. Okay?
Can you explain it again, please?
طيب. Let's look at it again. نحن for a stereogenic center we should have it should bond to 4 different groups. Okay? This one, what's the first group? The first one is an OH. The second one, it's bonded to a hydrogen. This is the second group. ماشي? H. ماشي? The third group is this thing. This thing, it's a group that has 2 carbons and an OH. This is the group. Okay, we'll name it like this. The fourth group is that it's attached to this whole thing. This whole thing has 1, 2, 3, 4, 5 carbons, right? 1, 2, 3, 4, 5 carbons. These 4 groups are different. That's what makes it a stereogenic center. ماشي? طب why is this one not a stereogenic center? Because it's only attached to 3 different groups. 1, 2, 3. ماشي? And if you remember at the beginning of the presentation, any carbon that has a double or triple bond, it's not a stereogenic center. Got it?
Oh, okay, got it. Thank you.
Okay. Fine. Let's scroll down. ماشي. The question is asking which of the following has the same molecule artist. This is A, this is B, this is D, C, and E. You need to find the same molecule as this. This is how the exam would look like, by the way. And I'm focusing on R and S mainly because in the midterm, I remember there was a lot. طيب يلا عشان time يلا I'll do this question. طيب.
C.
C? Okay, يلا let's
No. C.
Okay, let's find out. طيب, first of all, we need to find the R and S convention. Okay, so hydroxyl is always first priority, ethyl, then methyl. Okay, it's rotating clockwise, so it looks like it's an R, but it's actually an S. ماشي, because the hydrogen is coming outside. Okay, let's look at at A. A, yes, A. 1, 2, 3. ماشي, it's rotating clockwise, so this is an R because the hydrogen it's in its correct place. ماشي, طيب this one 1, 2, 3. ماشي, it's counterclockwise, but it looks it's not an S, it's an R because of the hydrogen coming out of the page. ماشي, but these two molecules are the same, so these two are incorrect. Now this is 1, this is 2, this is 3. ماشي, we rotate. ماشي, it looks like it's an S, but it's an R. So this is also incorrect. But now the last two. Number 1, 2, and 3. Rotating, it looks like it's an R, but it's actually an S. So yes, it should be C. Let's look at the last one. 1, 2, 3. Rotating counterclockwise, looks like it's an S, but it's actually an R. So all of them are R except C. Okay, yes, C. Here. Let me make it clear. Okay, good job. Think how many questions remaining? يلا, 3 questions remaining وخلاص. This is an easy question. Naming. True. Can anyone answer? Easy. Very easy.
It is R because it is counterclockwise. It is clockwise and
Okay.
It's A.
Okay. Yes, it's A. Okay. Let's first cancel out. Okay, the longest carbon chain is 5 carbons. 1, 2, 3, 4, 5. So it should be pen. Pen, pen. C, we cancel it. E, we cancel it. Okay. Second of all, this is a double bond. ماشي? So we cancel out D because it's saying 10 times. ماشي, but there is no triple bond. Lastly, yes, you look at the R and S and you solve it. Okay. This one was a harder question. Which of the following?
can you just screw a little bit to the right?
Zoom?
It's C.
C. Good job. طيب. ماشي, يلا. طيب, يلا, let's see why C. طيب. Which of the following 3 molecule is a diastereomer? ماشي, when we say diastereomer, it means one should have the same chiral center and the other one should be different. طيب, يلا. Let's first assign them. طيب. This one is the original molecule. طيب. We do it normally. This one is number 1. This one is number 2. And this one is number 3. It's rotating counterclockwise. That's because the H is on the wedge. ماشي? So it's not an S, but rather an R. Okay? So this one is an R. ماشي? Same thing here. 1, 2, 3. It's rotating clockwise, so it's not an R, but it's an S because of the hydrogen coming out. So this is the configuration of the original molecule. طيب. ماشي. Let's do it normally. This one, if you look at this side of this here, you'll find it's exactly the same. So no need to waste your time and do it again. It looks exactly the same. No need to waste your time. So خلاص, immediately put R. Okay? R. طيب. Now here. 1, 2, 3. ماشي. It's rotating counterclockwise, so it's an S. ماشي. The hydrogen is it's on its place. No need to invert our answer. ماشي. So this molecule is the exact same thing as this molecule, but this one is just rotated. Okay. Second one. We do 1, 2, 3, rotating counterclockwise, so it's an S. We do here command 1, 2, 3, so it's an R. So this one is the enantiomer. It's not the diastereomer because they differ in all of the chiral center. خلاص معناتها we're left with the last one. بس يلا let's do it fast. 2, 3, counterclockwise, it's an S. Here 1, 2, 3, clockwise. ماشي. بس the H is coming, so it's not R but rather an S. Okay, both S. ماشي. So here differ in carbon number 3. They are the same, but they differ in carbon number 2. Okay, good job. Okay, last question, I think.
E.
E?
Yeah.
Okay, good job. Yes, this one is incorrect. This one is the incorrect sentence because we talked about it. The R isomer, it could rotate to the right, it would rotate to the left.
Can you explain the first answer, please?
The first, they cannot be differentiated with a spectra. Can they be differentiated with the spectra? Yes, an example of a spectrum is the plane polarized light.
Oh, okay, thank you.
Okay, they have the same melting and boiling point. This is something correct. This is something correct. The mirror image of the R isomer is the S isomer. This is correct. The specific rotation of each isomer has the same magnitude, which means, if it rotates to the right 50 degrees, the other one should rotate to the left 50 degrees, any equal magnitude. So the last one is incorrect. Thank you, guys. Khalas, we're done.
Thank you.
Any question? Anything?
Can you go back to the last question?
This one?
Yeah. What did you say about answer A?
A. A is telling you that they cannot be differentiated with a spectra. Okay? ماشي. But they can actually be differentiated.
So that doesn't make the A incorrect?
They cannot be differentiated with a spectra. Which of the following... Okay, wait a second. Which of the following statements about the answer is incorrect? I think there is a mistake in the question.
Okay.
Yeah,
So
there
they
is a
can
mistake.
be differentiated, right?
Yeah.
So are there like two answers for this question?
لا 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 لا.
ولا هي A بس؟
لا. I wrote it A. I wrote it wrong.
Okay.
Okay. طيب. ماشي. Any other question? Okay. خلاص, I'm done with my part.